Well, welcome to this video for Math 127. We're going to take a look at 1.9. You might feel like that's kind of random since we've been working in other chapters, but it fits in well with what we're getting ready to learn next. So 1.9, we're going to look at circles, distance, and midpoint. And it's a lot of information that you've seen in other classes, maybe just putting it together in slightly different ways. So I'm starting off with the distance formula. When you were in geometry, you actually learned the distance formula. And here's the common representation of this formula. And just a quick kind of discussion about where does this come from. If I am thinking of some line segment and I create maybe one endpoint and name it as x1, y1, and a second endpoint and we name it as x2, y2. I can represent kind of the distance here between these two endpoints with the segment, but I could also drop down a horizontal and a vertical. Those are really awesome horizontal and verticals. I'm going to try again. Not much better. And I could find this distance of this hypotenuse or the length of the segment by using the Pythagorean theorem. And with the Pythagorean theorem, this vertical height right here would be the difference between the taller height and the lower height. And then the horizontal distance could be represented by the height further to or the x coordinate further to the right minus the x coordinate further to the left. And then if I think of this as a squared plus b squared equals c squared, where c is the hypotenuse, a could be the length of the horizontal side and quantity squared. B would be the length of the vertical side, quantity squared. And if I then wanted to isolate C, I could square root both sides in order to get C alone. And there's your distance formula. So the distance formula is essentially the Pythagorean theorem, just kind of customized through thinking of it through ordered pairs on a coordinate plane. So looking at some problems with distance formula, these are ones that are maybe just a little bit more complicated than ones you've done in past math classes because we're dealing with some fractions. We can have some square roots in here. So for the directions for these, we want to find the distance given that these are the endpoints, and we want to write our answers as simplified radicals and then also as decimals rounded to 2 decimal place. So for the first one, this distance could be represented by the square root of, let's see, the first or the second x coordinate minus the first quantity squared plus the second y coordinate minus the first y coordinate quantity squared. So simplifying the parentheses first, I would get negative 6/3, which divides out to negative 2 quantity squared. And let's see, this would be negative 2/4, which simplifies to negative 1/2 quantity squared. So whenever we square negative, it's a negative times a negative, which would convert to a positive. And then to simplify this, I'm going to go ahead and rewrite this with a common denominator. So let's see, this first ratio would become 16 fourths plus 1/4, which is the square root of 17 over the square root of 4, and the square root of 4 simplifies to 2. So this would be my answer written as a simplified radical. And then I could rewrite this also as a decimal. And we just want to make sure as we do that that we round that to 2 decimal places. So I'm just going to enter that real quickly on my calculator. And it looks like this would be approximately 2.06. We can also have these where we have some radicals in the problem. So the distance would be found by the second x coordinate minus the first x coordinate quantity squared plus the second y coordinate minus the first, didn't mean to have 2 minuses, minus the first y coordinate quantity squared. So let's see. I would end up with negative root 11 quantity squared, which is 11, plus negative square root of 21 quantity squared, which is 21, which is the square root of 32. And we do want to simplify these radicals, and since the square root of 32 is really 16 times 2, this would be 4 square root 2 as a simplified radical. which is approximately 5.66 as a decimal. The midpoint formula is also a formula you've done in the past. The midpoint formula could be written like this: x1 plus x2, the sum of x1 and x2 divided by 2, and then the sum of the y coordinates divided by 2. And probably the easiest way to think about these is what we're doing is we are just taking the average of the x and y coordinates, and that allows us to see what's in the middle between these. So we could, again, do these with integers or decimals or fractions or whatever. But in this case, I would have -8 plus -7 divided by 2. So I'm averaging the x coordinates. And then I can also average the y coordinates. And I'll end up with -15 over 2, or -7.5, and -2 over 2, which is -1. Also, something that you've learned before back when you took Algebra 2 is the standard form of a circle, which is x minus h quantity squared plus y minus k quantity squared is equal to r squared, where h comma k is the center of the circle, and r being the square root of that quantity that's isolated on one side, typically the right-hand side, is the radius of the circle. And so when we're talking about circles, we can also talk about domain and range. Now, circles will not form functions. They do not pass the vertical line test because for almost all of our inputs, there's exactly 2 outputs rather than exactly 1. But we can still find the domain and range of a relation. It doesn't have to just be of a function. So as a reminder, domain is talking about our x coordinates and talking about how far do our x coordinates stretch from right to left. And we're going to use interval notation for this. And so as a reminder, when you use closed brackets in interval notation, or when you use brackets like this, that's representing that you have a closed circle in that position, and open parentheses would show us for an open circle. And so if we think about what a circle looks like, it's a smooth connected graph. So we're going to be using the brackets here because these are closed. However, if you did have a different shape, you might be using open. You might represent an open circle with parentheses for domain and range. But domain, again, will be the x coordinates. And so the way we'll write them in interval notation is we will write down the farthest x value to the left, comma, the farthest x value to the right. And then range is our vertical, or looking at our y coordinates. And so we will look at the lowest height, and then a comma, and then the highest y coordinate, or the highest height reached by that circle. So example 3, we're going to write the equation of the circle in standard form. We are given the coordinates of the center, so this is h comma k. We're also given the radius, which is the square root of 23. So since the formula is h minus k quantity squared plus, let's see, x minus h quantity squared plus y minus k quantity squared equals r squared, we would end up with x plus 3 quantity squared, note the sign change, plus y minus 7 quantity squared equals root 23 squared, which would become 23. Example 4, let's say we are given a circle and we already have it written in standard form. We want to graph it and then state the domain and range in interval notation. So the center of this circle is h comma k, which is 2 comma 0. Since there's no number in the k position, we'll use 0. The radius is 4, which is the square root of that constant that's isolated, the square root of 16. So the center of the circle is 2, 0, and then we're going to go out 4 units in all directions. And I am super awesomely bad at drawing circles. It's like really comically bad how awful my circles tend to be. This is like one of the better ones and still pretty rough there, that lower left corner. But there's my circle. And again, the radius is 4 units long. The domain and range. The domain would again be the farthest left, comma, the farthest right. So the farthest left we ever go, despite my very poor looking graph here, is -2. And the farthest to the right we go would be the farthest to the right at that same height as the center, which looks like 6. range would be the lowest height, which is -4, and then the highest height, which is +4. Oops. And we will use brackets here because circles are made with, or circles are graphed with closed circles here, or closed points, when it's a smooth connected graph. There are times that the circle is not already written in standard form. If you need to write it in standard form, you would need to complete the square in order to do so. So it may have been a little while since you've done completing the square. So I'll remind you really quickly of how you can do that, and then we're going to graph it from there. So when you complete the square, you want to group together all of your x terms. I usually then leave a space for the constant that I'll be adding that would create a perfect square with the x's to create a trinomial there. And then I'll group together all the y terms, and I'll be adding in another constant. I'm going to move that constant of 20 over to the other side, in which case it would become a negative. And whatever the constants were that I added to complete the square for my x and y trinomials that I'm creating, I'm going to balance my equation, and the exact same constants will be added to both sides of the equation to keep this balanced out. And that will also help me identify what r needs to be in order for this to be written as a circle. So when you complete the square, you want to take the coefficient of b, divide it by 2, and square it. And that's going to be what you add to both sides of the equation. When you are completing the square again with y, you'll take the coefficient of the b term from the y trinomial, divide it by 2, and then square it. And again, that will get added to both sides of the equation. Now, if there is a leading coefficient in front of the x squared or the y squared terms, there is just a little bit more of a distinction there. You would have to factor that out. And then when you add to both sides, you have to add that times what you factored out from the GCF. And we'll go through that when you look at your 9.0 notes. But then I'll factor the trinomial that I formed with x, which would be x plus 3 times x plus 3, or x plus 3 quantity squared. This is going to give me my h value. And then when I factor the trinomial with y, I'd have y minus 6 times y minus 6, or y minus 6 quantity squared. And then when I combine all of my constants on the right-hand side, I would get 45 minus 20, which is 25. So the center of this circle, so here it is in standard form. The center of this circle, h comma k, note the sign change would be -3, +6. Hopefully I did a good job counting there. The radius would be the square root of the constant that's isolated on one side, which would be 5. So I'll move 5 units in all directions. And then attempt to draw a circle. And it's again a rather sad version of a circle, but I'll let you use your imagination there on that one. And that is the end of your notes for section 1.9.